Alright, today we'll be starting proofs. Okay, before we start proofs, we're going to learn a little bit about theorems, and then we'll show you how to set up a flow proof in geometry. First off, a theorem is a mathematical statement that can be proven. Okay, first theorem, if two angles are right angles, then they are congruent. Okay, our shortcut for this is all right angles are congruent. Actually, I'm going to take out the R and just say all right angles congruent to make it even easier. Alright, so we're going to justify this theorem. This will be used as a reason for our proofs. Okay, but for now we're going to justify it. Okay, I'm going to prove why it will work using a flow proof. So first, when I start my flow proofs, I underline my givens. So I'm going to rewrite them below. Angle A is a right angle, and angle B is a right angle. Okay, I'm going to go ahead and underline them. Now, before I use this reason, I'm going to justify them. What do we know about right angles? We know the measure of them is how many degrees? We know it's 90 degrees. So I can say now they're 90 for both. Okay, so I can say because the angle A is right, we know it's 90 degrees. Now there needs to be a reason for everything I say in the proof. So how do I know that a right angle is 90 degrees? Because of the definition of a right angle. Okay, now these two reasons are the same, so I'm going to put a 1 twice. Okay, now because I know that they're both 90, I'm going to say that the measure of angle A is equal to the measure of angle B. Okay, now this is called substitution, because what I'm doing, because they equal the same exact thing, I'm substituting angle B in for basically a 90. This is called substitution. And now because they're equal, I can now say angle A is congruent to angle B. Okay, and that'll be my third reason, different than the other two. And how do I know that? Well, anything equal, any measures that are equal means that they're congruent, and that's the definition of definition of congruency. Okay, so this is justifying this reason here that all right angles are congruent. Now that I proved it, I can now use it in a proof, which I will show you below. Second theorem has to do with straight angles. So it's very, very similar. Just now they're not right angles, they're straight angles. So we're going to say if two angles are straight, then they are congruent. Okay, shortcut is all straight angles congruent. Alright, let's justify it by showing you a proof. So again, I'm going to write my givens out and underline them. Go ahead and do that now. Okay, so angle ABC straight angle DEF straight angle, and they should be underlined. What do I know about straight angles? I know that their measures equal. I hope you know a straight angle equals 180 degrees. If you know that, then we're doing good. Same with DEF is 180 degrees. Okay, now what's the reason for that? Similar to the one above. This is going to be our first reason. Reasons I'll put over here. Why do we know a straight angle is 180 degrees? Well, we know that's a definition of a straight angle is 180. Okay, exactly how I did the proof before. I can now use substitution by saying the measures of ABC. Squeeze in a measure. It's equal to the measure of DEF. Okay, that reason will be substitution. And then my last step, because they're equal, we can now say angle ABC is congruent to angle DEF. And that's step 3, definition of congruency. Okay, so once I get to this last proof here, what I want to prove, I'm done. These two should match. All right, now that I proved those two, I'm going to go ahead and use the two theorems in a proof. So now I have diagram as my given. Okay, sometimes I'll just give you the diagram. So if they do that, you can write a D and underline it. That's going to be your given. And I can pull a couple things from the diagram. Okay, I know that angle APR is what type of angle? Straight. And angle SPB is a straight angle. Okay, so I gave you a shortcut up here in the theorem. We proved them. So now we can go ahead and say that because we know they're straight, we know all straight angles are congruent. So I'm going to go ahead from straight to angle APR is congruent to angle SPB. Okay, so theorems always just skip steps, which you'll find out soon. How can I go from a diagram to straight angle? My first reason is going to be we can assume straight angles. That's one thing that we can in our assumptions. And how do I know that straight angles are congruent? Because all straight angles congruent. Okay, and that's the end of my proof. Okay, I'm going to do the exact same thing with the right angles. So go ahead and write this one out exactly like this, but instead of the straight angles, you're going to say something else. Go ahead and try this one on your own. Okay, so I wrote out the given. Angle A is a right angle, angle T is a right angle. Now I know they're both right, so I can go ahead and jump to angle A is congruent to angle T, because I have a theorem that tells me all right angles congruent. So, all right angles congruent. And that one was easy. It was only one step. Okay, moving on. All right, we have EFG congruent to HFG. Okay, so I'm going to put D for diagram, and I can assume a couple things from the diagram. So I can assume that angle EFG is straight, and HFJ is straight. Okay, and I can go ahead and say why. The reason why I can assume that is because I can assume straight angles. Okay, if they're both straight, then I can go ahead and jump to they are congruent because all straight angles are congruent. EFG is congruent to HFJ. Reason why, all straight angles congruent. Alright, last one's a little bit harder. It's got 5 steps, so bear with me. Ready? Angle RST is 50, so we know this one is 50 degrees. We know TSY is 40, and we know angle X is a right angle. Okay, so we're trying to prove RSY is congruent to angle X. How do we do that in a proof? So I'm going to go ahead and write off these two givens together, and angle TSY is 40 degrees. Now what I want to do is add them together in a proof, and to do that, I'm going to use the angle addition postulate. So from the diagram, I can say that angle RST plus the measure of angle TSY equals the measure of angle RSY. Okay, these two pieces, RST ATSY equals the entire angle RSY. Okay, so what I'm going to do is substitute 50 in here, 40 in here, and now I can say measure of angle RSY is 90. Okay, so I have to go ahead and put my reasons. Every time I have an arrow, I need a reason. So this is 1. Let's say this one is going to be 2. Okay, so I mentioned this before. Remember, this is called the angle addition postulate. Angle addition. Okay, can always take that from a diagram. And 2, what's actually happening in this picture, the 50 is replacing over here and the 40 is substituting over here. That's called substitution. Okay, so now I have that this one's 90. I'm going to say now that this is a right angle, because I could easily say that that is also 90. So I'm going to say angle X is a right angle. That's given. What could I say from that? Can I say that angle X is 90 degrees? Measure of angle X is 90 degrees. Okay, and what that reason would be, I mentioned it earlier. How do I know a right angle is 90? Definition of right angle. Okay, so I have them both equal to 90. Okay, now I can't say they're congruent right off the bat. I have to use substitution again and say their measures are equal. So before I say congruent, I have to say the measure of angle RSY is equal to the measure of angle X. Okay, so that would be step 4. Substitution again. Because I'm taking, and they're both 90, so I can substitute them in for each other. And last but not least, I can now say that angle RSY is congruent to angle X. And this one I mentioned before. Definition of congruency. Okay, and that ends the session on Intro to Proofs. What we're going to do on our first quiz, we'll practice giving just reasons. You'll have a proof already set up like this, and you'll have to practice giving the reasons of why it goes from, say, this portion right over here, the proof, to this one right here. Have a good night.